During this educational video, we will review how to determine which style of swing-out valve you have if replacement parts are needed. We will begin by looking at the basic features of the swing-out valves, and then cover how to identify current and past styles produced by Akron Brass. Additionally, we will cover the most common valve controllers along with some of their features and limitations. Finally, we will take a look at where to find additional literature and documentation for these and other Akron Brass products. This exploded view of the valve shows the various components as well as several of the available handle options, which we will cover in a bit. The stop plate is located immediately below the handle and is what limits the rotation of the handle and ball. The trunnion retaining plate is attached to the valve body, and along with keeping the trunnion in place, as the name would imply, it also contains the stops that are contacted by the stop plate. The ball trunnion, also known as the handle trunnion, physically connects the handle or actuator to the ball. Additional components include the valve body, the threaded trunnion, ball, seat, and adapters. Here's a quick review of the available handle and actuator options for the swing-out valves. The TS and TSC handles are identical except for the addition of a decorative handle cover for the TSC. The R1 handle attaches to a linkage for a push-pull operation at the pump panel. The SZ handle can be turned to lock in place. The rack and sector operate similarly to an R1 handle, but uses a sector gear to provide a constant torque when opening and closing the valve. The last two, the electric and manual gear actuators, use reduction gearing to assist with valve operation. Not shown in this selection is the air actuator, which is only available for use with the 4-inch valves. Another important thing to know is how to determine which size of valve you are working with. This can be done by measuring the size of the valve body. The recommended method is to measure the bolt spacing of the valve, either diagonally or along one side. The chart shown here lists the valve sizes and their corresponding bolt spacing, and is part of the valve guide, which can be downloaded from the Akron Brass website or found in the technical section at the back of our product catalog. The bolt spacing for a given size of swing-out valve has remained unchanged through the different valve series that have been produced. Now let's move on and look at the valve groups. The original swing-out valves were the 76 and 7800 series. Both used the white composite ball, and while the 7600 series are non-locking, the 7800 series are self-locking. The 86 and 8800 series of valves were introduced later and use a stainless steel ball. The 76 and 7800 series of valves were still produced during this time, but they were later replaced by the 8900 series valve, which use a new composite material when Generation 2 of the 86 and 8800 series valve came out. One additional note, the self-locking feature of the 7800 and 8800 series valves does not actively lock the valve handle in place. It merely provides enough resistance to keep the valve from drifting shut if it is being operated in a semi-open position. Now let's cover the specific valve series. The 7600 series valve came in two versions. The older version on the left was produced until 1988. It has a trunnion retaining plate with handle stops machined into it that is fastened to the valve body by 6 screws. There is no stop plate since the stops are tall enough that the handle itself limits the degree of travel. The later version of the 7600, shown here on the right, did away with the trunnion retaining plate and cast the stops into the valve body. It also introduced a stop plate since the handle now clears the stops. Some, but not all, of the later versions of the 7600 have the style number cast into the side of the valve body for easier identification. The 7800 series valve also came in two versions. The older version on the left was produced until 1987. Like the 7600 series, it used the trunnion retaining plate with 6 screws. In fact, the only easy way to tell the early 76 and 7800 series valves apart was to check for the presence of the two-piece handle trunnion that was part of the self-locking feature on the 7800. The later version of the 7800 kept the trunnion retaining plate, but changed the design to only have 4 screws connecting to the valve body. It also includes a stop plate for the newer style handles. There is almost no visible difference between the Generation 1 and 2 version of the 8600 series valve, since it was designed for use with a gear or electric actuator. It is important to note that with the introduction of the 8600, the rack and sector actuator was redesigned and requires a valve body specific to that actuator, meaning that if you have a rack and sector and wish to switch to a different actuator, the valve body will need to be replaced as well. The first generation of the 8800 series valve, shown on the left, was based off of the later style 7600 series valve. Like the 7600, the valve had cast-in stops, and the style number is cast into the body of the valve for ease of identification. Generation 2 went back to the universal valve body with a separate retaining plate. At this point, the Generation 2 valve should be distinguishable from the much earlier 76 and 7800 series valves based on the valve stem and the shape and size of the trunnion retaining plate. The other thing that clearly marks a Generation 2 valve is the G2 cast into both the sides of the valve body and the inside of the valve ball. The main advantages with the Gen 2 design is that it is a universal body, which allows you to mount your choice of all of the various handles and actuators to the same valve body, with the previously mentioned exception of the rack and sector. It also allows the valve actuator to be changed without removing the valve body from the waterway. The 8840 gets special mention here because it differs from the rest of the swing-out valves in that it is more like a butterfly valve than a ball valve. This is done to reduce the length of the valve body. Another distinction with the 4-inch swing-out valves is that they can only be used with actuators, not manual handles. An important note for the 8840 is that before switching between types of actuators, check to make sure that it doesn't require the replacement of the trunnion and flat ball as well. Next, we're going to quickly review an issue common to changing out the seat kit on the 8840. The biggest issue when installing a service kit on the 8840 is to make sure that the brass seat ring installed in the seat is not discarded. While there is a new seat in the service kit, the seat ring must be reused. If it is not installed, the valve will likely leak and possibly start blowing out the O-ring between the seat and the valve body. This is what the completed seat assembly should look like, both when it is removed from the valve body and when it is reinstalled. Note the presence of the seat ring between the white seat and the wave spring. While we are on the topic of service kits, the compatibility chart for service kits can be located in the valve guide on the Akron Brass website. The kits are backwards compatible, meaning a kit for a Generation 2 valve will work with any of the older valve series as well. Also, the type of ball can be swapped out, changing between a stainless steel and composite ball. The 8900 series valve was introduced with the Generation 2 valve design and replaced the 76 and 7800 series valves as the composite ball option. The 4-inch valve body is larger than that of the 8840 since the 8940 uses a 4-inch ball instead of the butterfly style design of the 8840. This ends the section on valve styles. Now we're going to move on to briefly look at controllers for the electric valve actuators. These are some of the most common valve controllers. It is important to be able to recognize them and know some of their differences and limitations. For instance, all of these will control a valve, but only the 9315 and 9325 add the ability to display readings from pressure and flow sensors. Also, the setup for a Navigator Pro controller is significantly different from that of previous controllers. In practical terms, this means that you can upgrade from a 9303 to a 9315 by swapping out the valve controller, but it is more involved to update from a 9303 to a 9325. Let's take a closer look at how the Navigator Pro line differs from previous controllers. The biggest difference between the Navigator Pro series and previous controllers is that where earlier units were self-contained and only sent power to the valve motor or received sensor inputs, the Navigator Pro splits the electronics between the display and a motor driver that is installed on top of the electric actuator. The motor driver handles connections to the motor and any sensors that are installed. The fact that the controller is no longer a standalone unit is why upgrading to a Navigator Pro system is more than just swapping the display unit. The advantages of splitting up the electronics are that it allows for more flexibility when wiring multiple controllers and valves and uses less system wiring. It also allows the addition of a position sensor to the electric actuator. To find product information and parts lists, visit our website at akronbrass.com and search using the product name or style number, or look in our Technical Document Center located under the Customer Support section of the website.